Alrighty, so what we have here, we need to put together the hardware that can do this operation. Well, the operation itself is implemented by the ALU, and so we're sort of treating that as a black box. It takes in two 32-bit operands, and it produces a 32-bit result, and it takes in a 5-bit opcode. Right, and so part of the job of the control logic is to take the 6-bit instruction opcode, okay, and produce the appropriate 5-bit control signals, the 5 control signals the ALU needs to decide what operation is performing. So we're going to be putting in the 6-bit opcode into the control logic, and we're going to be getting out two things, at least so far. One is a 5-bit field which tells us, which is directly the 5 bits that control what function the ALU computes, and the 6th bit out of the control ROM is an instruction called WRF. You can see the dog here, WRF, WRF. And so you'll never forget WRF once you imagine the little dog barking away. WRF is actually write enable register file. One of the funniest things to do is to get a bunch of engineers in a room who've looked at a schematic, and they've all sort of anglicized all the names of the signals in the schematic. And of course, people pronounce them differently, right? So how would you pronounce, ALUFN? Alfun, and what happens, everybody chooses a different way of pronouncing it. So you say WRF, and I'm going, what the beans is WRF? And you say, well, that's W-E-R. Oh, that was wee-woof or something, So bear with me. I actually, will have pronunciations for all of these signals. But I'll try to be as clear as possible. Okay, and so you can see that we send the RA and the RB field as addresses into the register file and get out the two 32-bit operands. Right, so we're sending in two 5-bit addresses, which selects one of the 32 registers, and what comes out the bottom and the two 32-bit read ports of the register file are the 32-bit contents of the two selected registers. Those become the operands into the ALU. The function that's being performed is determined by the 5-bit ALU function code, and it uses the information it operates on are these two 32-bit operands. The 32-bit result is fed back into the right data wires of the register file, and at the rising edge of the next clock, assuming WRF is true, which it always will be in this case for all the ALU instructions, we will write the result into whatever 5-bit number appeared in the RC field of the 32-bit instruction. Now, we're going to spend the next 20 minutes adding a few more things, but this data path is actually remarkably close to where we're going to be at the end. And so this is a good moment to ask any questions you have about this simple version. Yes? When it's false, everything works just as it worked before, except that this 32-bit data coming out of the ALU will not be written into any register of the register file. So it's not safe to put into memory anyway? If WRF is 0, then the machine will not remember the result the ALU computed. And you'll see that there's exactly one instruction in our entire instruction set that does not write into the register file, and hence WRF is 0. Yes? Right, we'll get there. So, hold on. It's tempting to run ahead because the story unfolds pretty quickly. But 2 more clicks and I'll be there too. So, okay, no other questions? Yes.
So the two addresses that go into the register file.
Yes, RA and RB fields from the instruction. In the earlier thing, we called them A cell and B cell. That will turn out to be an unfortunate terminology, as you'll see in just a second. So just think of them as the RA field and the RB field.